We are going to look at some sample problems involving populations, samples, and the different types of sampling techniques. On this first question, they're telling us that 4 scenarios of statistical studies are given, and we're to decide which one uses a population parameter. So remember, population refers to the whole group, not a part of a group, the whole group. And then within that population, we're going to have some type of parameter, which is numerical data. So on this first one, it says, as part of her senior project, Kaisa asked 84 of her classmates. So if she only asked 84, that's not the whole group. So that would not have anything to do with a population if it's not the whole group. The second scenario, it says 1,000 of 1,883 participants were interviewed. So again, this is not the whole group if we're not interviewing people based on the whole group. The third one, we have 15% of the attendees at a town council meeting. Now, what we're focused on is their internet use. Are they the only ones who use internet in the town? Probably not. So once again, we're not looking at the whole group. Finally, the last one says, in 2001, 78% of children diagnosed with cancer were in remission after 5 years, and this number is improving. So we're looking at all the children, so that would be our population, the fact that they're looking at those children, and then the parameter is the fact that 78% were shown to be in remission after 5 years. So this would be a study that has a population parameter. Okay, same thing, 4 more scenarios, but this time we're looking for a sample statistic. So we have to focus on part of a group, not the whole group, and then the statistic would be whatever numerical aspect of that group we're looking at. So the first scenario tells us the National Institute of Pediatric Dentistry reports that 42% of children ages 2 through 11. Now, if we're talking about children ages 2 through 11, we're talking about a whole group, not a part of the group, because they didn't say, 500 of those children. So this would not be related to a sample. If we have a study prompted by the increase in the use of assisted reproductive technology, and they looked at hospital records across the country, again, they're not sampling. They're looking at an entire group, so it's not a sample statistic. All right, the third one, an estimated 15% of Americans. Again, we're looking at a whole population, not part of a group. And then finally, on the last one, if we're only going to look at 1,000 out of 1,883 participants, that is a sample. And it said out of those 1,000, 68% said they became interested in triathlons after first competing in a marathon. So there is your statistic based on a sample of 1,000 out of 1,883. Okay, on question 3, it asks us to identify the population, the sample, and any population parameters or sample statistics in the scenario. So we're looking at average number of hours that students in your statistics class study per week. Okay, so here is that number, 10.1 hours. Now, they're not talking about a whole school. They are specifically looking at students in your statistics class. So that would be your population, students in your statistics class. They didn't say anything about wanting to know how many hours per week students at your school studied. So it's just those in the class. They obviously did not sample. They obviously looked at the whole class, so there's not a sample given. And then, of course, the parameter that they're talking about is 10.1. So when we look at our answers, so population is students in your statistics class. That is true. We do not have a sample of students at your school, so that is not true. So again, the population is students in your statistics class. There is not a sample given, and because we're based on a population, 10.1 is known as a population parameter. So notice that the third one is wrong because we didn't talk about all the students at our school. That's not true. And the last one is wrong because if we're basing the students in your class being the population, we're not going to refer to this as a sample statistic. It is a population parameter. All right, question 4. We're asked to identify the sampling technique. So we have a local polling center collects data from voters by interviewing every 15th person. So every 15th person that comes out, they are going to interview. That is known as systematic. When you have a system in place and you say, I'm going to interview every 10th person, or in this case, 15th person, that is known as systematic sampling. And then last, we have an investigator who wants to know what types of vehicles access the highways in his city during the past week. So he has access to traffic camera footage of each highway entrance ramp for that time period, but he doesn't have time to find a pattern in the footage or view it all. So his sample does not need to be truly representative. So in this case, because he does not have time, he is going to do what's called a convenience sample. He's just going to look at enough footage to figure out what he's needing to figure out in terms of the pattern. So remember that random is going to be where you just totally go in, like choosing numbers out of an actual hat. Cluster and stratified are both based on groups. Cluster is where you put them in groups where they're similar to the population. You pick certain groups and you sample everybody, whereas stratified, remember the word strata, you divide people up by things like age or gender or grade in school, and then you just randomly go in and sample people from each of those different groups. And then of course we have the systematic, where on the previous example where we looked at every 15th person.